your book, Existential Physics, begins with a mental health warning. Why did you put that in there?
Because I have gotten a lot of emails in response to what I've written and said about the absence of free will. So I think that we don't have free will, and it made me realize that some people find it hard to cope with. And they ask me, like, so what's the point of life if we don't have free will? To which I don't really have a good answer. So I wanted to put this out, at the beginning. It might, and personally, I found it very difficult. Like when I was a student, studied physics, so you get to the point where you're like, okay, so that's how everything works. Like this is like fundamentally, this is what we're all made up of, right? Atoms, and they do this thing, and so where's the space for free will? And we can talk about this in more detail, but it's taken me some time to wrap my head around it and get comfortable with it. And so I wanted people to know what what they are getting into, basically.
Yeah, I suppose there's an expectation sometimes on physicists or indeed philosophers who come up with these crazy ideas like free will doesn't exist, or there's no such thing as ethics, or questions about God or whatnot. And then people come to them and say, oh, so what should we do in light of that information? And
Right.
it's like,
Right.
well, how should I know? I'm just here to diagnose a problem or tell you something I think is true. It's up to you to figure out how to deal with that. But do you recognize, I mean, in the areas you touch on as a physicist, you're talking about free will, you're talking about consciousness, you talk about God sometimes. Do you recognize the desperation in comments like that? Like when someone says to you, I'm having an existential crisis, do you say, I'm sorry to hear it, but, I don't relate to that? Or is that something that you also have sort of gone through, but just managed over time to deal with?
Well, yeah, I did go through it and I managed to deal with it. And no, I definitely don't ignore such comments because I'm kind of I worry about people. And I try to help them because I mean I kind of managed to make peace with it and I try to convey that to people, but still I don't know, does it actually work, right? So that's why I worry. I understand why people might find it hard. Like what's the purpose of anything? What do I do? What do I do with my life? Why do anything? Um, so I kind of feel like I'm a little bit the wrong person to talk about it, but I feel like I can't not do it basically.
Yeah. Well, what are the principal areas? You already mentioned free will, which I think people can understand why not believing in free will would cause an existential crisis. But some people might be surprised to think, I thought that Alex's guest today was a physicist. And yet we've opened here by alluding to these existential problems, which are usually in the realm of philosophy. So what other areas can a physicist be writing about and touching on that get people to send you emails like that?
So one rather obvious question or topic that physicists like to talk about is the beginning of the universe or the origin of everything, as some people would put it. And generally, like the question, like where is space for God? Anything beyond the fundamental laws of nature? There's also, and this has become much more widely discussed in the past 2 years with AI being everywhere. Is there anything special about consciousness? Or, I mean, this
Hmm.
is the way that people put it, but I think what they really mean is there's something special about us.
Yeah.
Right. And I think some people find this really, really important. Like there's something different about us that we can't build with a machine. And I just think there isn't. Basically, I think we're all machines in some sense, just made out of other stuff, and there's no reason why a computer shouldn't be able to become conscious. And I do think that physics has something to say about it because fundamentally we're all made of atoms.
Yeah. Yeah. I mean, you have a whole chapter in your book It's called something like "Are We All Just a Bunch of Atoms?" or something like this, which discusses this idea of what, if anything, makes human beings or sentient minds special. And yeah, I mean, it does feel as though there's me and there's, this microphone that's sat in front of me, as I like to point to as an example all of the time. And well, what's the difference between them? Okay, the size, shape, and color, but it also seems like there's something that there is like what it's like to be me in a way that there's not a what it's like to be the microphone. And that seems to have something to do with the internal first-person perspective, feelings, the fact that I can close my eyes and imagine things that the microphone doesn't have. So I've spoken to philosophers about this over and over again. Where does this consciousness thing come from? But from a physicist's perspective, if we are just talking about atoms bumping together, you can understand why people find it so difficult to imagine that if you throw atoms together in the right order, you create a rock or a microphone or some water. Or if you put them together in the right order, then you get first-person conscious experience and imaginary rocks and imaginary numbers and all kinds of stuff like that. That just seems totally incomprehensible for some people.
Yeah, well, so I want to start by saying that the German title of the book is Mehr als nur Atome, which means more than just atoms. So the point is, we're more than just atoms. So it's not just about the things that we're made of. It's about the way that they're connected. It's about what they can do, which is exactly what you just said, right? So the human brain can do more than your microphone. It's just much more complex. So that's the question. Like, is this the only thing? Like, is this the only difference? That the human brain has just many more connections, many more things going on, and it has many more emergent features, as philosophers like to put it, than your microphone. And I think the answer is yes. That's it. It's at the moment the human brain is much more complex than anything else we can think of, but it may not remain that way. And so, it's a related argument that I bring up in the book is this question like, do we actually need these atoms? Or can we make it of something? Can we build consciousness from something else? So there's the question like, do we actually need this particular biological substrate, so to speak? Is it somehow essential? And I think that physics tells us that the answer is no, because we know that the exact details of what's going on beyond a certain scale, at very short distances, actually don't matter for exactly how information is being sent around in the brain. It's got something to do with the way that things are connected. And that makes me think there's no reason why we shouldn't be able to reproduce this with some other system, be it silicon or whatever they now work with. I always hear people talk of graphene, but it never seems to become reality. Yeah. So I totally think you can do it on some other system. That doesn't mean that we've actually managed to do it yet.
Yeah, sure. I mean, I think for a lot of people, they sort of just have this confidence that one day we'll work out how that process would work. But if we could conceivably just put atoms together in the same way, there's that thought experiment of replacing every neuron in your brain with like a transistor or something, And if you just replaced one single neuron with a transistor or some kind of silicon, would you notice a difference? And the answer is like, no. I think everything would function the same, and the brain would still act in the same way. And well, if you just kept doing that over and over again, at what point would consciousness switch off? It kind of seems like it wouldn't, right? But on the other hand, there is this feeling that, the question I always ask people is quite visually laden, but a lot of people can't visualize things in their head. I don't know if you're one of these people who can close your eyes and imagine the color red, for example. Some people say that they can't, some people can, but at the very least you can probably imagine a triangle, right, in your head if you think of it, and it's got three sides, and there are things that are true and there are false about it. And so, is it your view that, say, this triangle that I'm picturing in my head right now just somehow is the same thing as some kind of atomic structure within my brain. Because I think the dualist will think, no, that triangle exists in the mind because it's got spatial extension. It's got 3 sides, for example. Your brain, the atoms in your brain doesn't have those properties. So what's your view on that discussion? Like, what is this triangle? Where does it exist? How does it exist?
Yeah, I wouldn't call it an atomic structure because that makes it sound like it is some sort of material in your brain that you're
Right.
assembling. But it's something something that's going on in the circuits in your brain is what I would say. Yeah, actually, I think we don't even have to speculate about this because people are now doing brain experiment, not my area, but where they can basically read out what images people are thinking of. And so, I mean, it's, at the time, it's not great, but at some point, we'll probably be able to do it.
Back to the show in just a moment, but first, do you trust the news? I don't, and a lot of that has got to do with the bias that inevitably seeps into media reporting. We can never get rid of media bias, but wouldn't it be great if there were a way for us as consumers of news to navigate the online media landscape, objectively comparing how different sources are reporting on the same story? That is exactly what today's sponsor, Ground News, allows you to do. Ground News aggregates thousands of local and international news outlets all in one place, so you can compare reporting across the political spectrum. Try it out at ground.news/AlexOC. Take a look at this story about Canadian and European space agencies reaffirming their relations amid political and economic anxiety. This is pretty great to hear, but I can see on Ground News that for whatever reason, of all the sources reporting on this story, 92% of them lean to the left, and none of them lean to the right. This means that if you only tend to read right-leaning news, you could have missed this story altogether. Ground News even has a dedicated blind spot tab, which specifically seeks out stories you would otherwise miss based on the news you normally read. It's a brilliant tool, and you can try it out for yourself at ground.news/AlexOC or by scanning the QR code that's currently on your screen. Use my link to get 40% off their unlimited access Vantage plan. With that said, back to the show. Yeah, I see. And so, like, by looking at the brain structure, we'll be able to sort of see what it is that they're picturing in their heads, something like that, which at least shows an intimate connection between those two things. But for me, I've always tripped up on this mystery of the line between like the mental activity associated with the experience and the experience itself. In philosophy, the experience itself, as separate from the mental activity, there's a word for it, they call it qualia, right? And you've just put out a video about how science might have something to say on qualia. It's often thought that that's kind of where the science-philosophy divide is with consciousness. Science deals with the brain, philosophy deals with qualia, but what is it that was, interesting enough about the relationship between science and qualia that made you think you need to make a video about it recently?
Yeah, so maybe let me say a more general thing. So I do these science news. I report on what other people do. So it's not that I did this research or something.
Yeah.
And so what the video was about is that I see this trend of people work in neurobiology or neuro something who write papers about how they've measured qualia. Like it's a thing. And so the video was about this trend, basically, that it's this qualia is moving from the side of philosophy to the side of science, where they just go and measure it. At least they call it qualia. I guess that there are philosophers who would disagree that this even is qualia. So of course, if you define it as something that's unmeasurable, then we don't have to talk about it because you've defined it that way. So that makes it by definition unscientific. But I think if you're talking about this spirit of what was qualia supposed to be, like this subjective experience, then you can measure it. It's something that's going on in your brain circuits. Of course, that doesn't mean that somebody else can experience exactly the same. Because, well, I would say the only way that somebody else can experience the same as some other persons if they actually are that person. So that doesn't make any sense.
Yeah, that's interesting what you just said about defining your terms. It's like Well, okay, scientists are beginning to study qualia, but philosophers look at that and go, well, the fact that you're studying it means it can't be qualia because, qualia is something that can't be measured. When you think of like redness or a triangle in your head or something, do you like understand the philosopher's critique where they say that there is something about that individual experience of redness which is just inaccessible to the scientific method? As in, like, do you think that it's appropriate to call qualia that thing which is inaccessible to science, or are you sort of more optimistic about the breadth of what science can do?
I don't know what the part would be that's inaccessible to science. So you do have an experience. We can measure that in principle, maybe not in practice yet, but in principle we could. So I don't see what else there is. I'm sorry, I'm a physicist all the way down.
The famous Mary's room thought experiment. There's the
Yeah.
girl in the room. So for the audience, there's a girl in a room called Mary, and we can imagine that she's given access to all of the information that could exist about the color blue. That is not just like the Wikipedia page that we've got today, but like every bit of information we could ever have about the wavelengths, about the science of the eye, about the psychology of the brain. She reads up and is an expert on all of it, but she's never seen the color blue. But she knows everything that could be put into words about the color blue. And the question is, if she then, after learning all of that, walks outside and sees blue for the first time, does she learn anything new? And for a lot of people, intuitively, the answer is yes. But if the physicist says that everything about the experience of blue can be described in sort of scientific language, would you therefore say that she doesn't learn anything new when she steps outside of that room? Or is there some sort of third answer that I'm missing?
First of all, I'm now super confused because I thought the color was red and not blue. But I mean, you never know. Maybe her blue is my red or the other way
Yeah,
around.
exactly. Yeah, who knows?
Yeah. No, of course she learned something new when she gets
Uh-huh.
when she goes outside because suddenly she has photons of a certain wavelength hitting her eyes and that sparks some reaction which she didn't have before. So it's just a different thing. So of course, just having a physical sensory input isn't the same as learning everything about what the brain does in response to that input. So those are just two different things.
I see.
So I guess the question you could ask is like, imagine she had all this information about what people experience when they see the color red or blue, whatever, and she also had a sort of brain stimulation machine uh, by the help of which she could, excite certain neurons in her brain if she knew exactly what to do. Would she have the experience of seeing the color red? And my answer to this would be probably yes. Going by everything we know about how similar brains are. Now, you could always argue that, of course, strictly speaking, your red isn't exactly the same as my red because our brains are slightly different. But I would say, well, they're probably similar enough.
That's really interesting. I guess that would count as a third option, which is that to sort of truly know everything about blue without seeing blue, you would also know exactly how to prod the brain in the right way to bring about the experience of blue, such that if she had the correct equipment to prod the brain in that way, she could bring about that experience of blue and learn what that experience was like without actually seeing something blue like in the room. Is that what you mean?
Yeah, right.
That's interesting.
So you don't actually need the photon hitting your
Yeah.
eye if you know what it does in response in your brain, basically.
I see. That's cool. That's cool. And so the center of consciousness is the brain, and consciousness is just like the product of complex arrangements of things or something like that. Like atoms arranged in a complex enough manner gives this centralized experience of consciousness. Because one of the other mysteries is like why if there are lots of moving parts all put together, why there's like this one singular, center for the consciousness,
Yeah, well, so I think at this point it gets very difficult because we don't actually know exactly how consciousness works, and everyone has their own theory about it. And I think it's probably quite complicated. You need different specialized parts of the brain that do different things. But
And you think
yeah,
that that's ultimately going to be a scientific rather than a philosophical question, or do you think that that's a bit of a phony distinction?
I think it's going to move from the philosophical realm into the scientific realm, and we're witnessing this move right now, basically. So at the moment, I think if you look at those theories of consciousness, they're all very, very basic. And I find them all quite unconvincing. But I don't know. Give it 100 years. Who knows if AI comes and they'll solve the problem in about no
Yeah, yeah.
time. Yeah.
There is also this, I guess, perception amongst some people that science and philosophy are at odds, to the extent that a lot of physicists look at philosophy and sort of think that it's a watered down or ancient version of what the physicist is doing. I'm thinking of people like Lawrence Krauss who've just said that philosophy is kind of nonsense. I think it assumes that there's like an empiricism to knowledge, that like anything that can be meaningfully known is something that is open to the scientific method, is testable, that kind of stuff. Given that you've written quite extensively on what people would call philosophical topics in existential physics, what is your relationship to philosophy generally? Do you look at it that way, or do you have a bit more time for it?
Well, I'd say there's good philosophy and there's bad philosophy,
Oh yeah.
but so you need to know what to look at. But actually, I think there's a second order problem with the physicists that look down on philosophy, which is that a lot of philosophers think that all physicists look down on philosophy. So I get a lot of hate from philosophers
Yeah.
because I'm supposedly dismissive of philosophy. And I'm like, no, I'm just dismissive of what I think is bad philosophy, like panpsychism, if you want to talk about this
Mm.
at some point. But no, I actually think that most physicists, and I totally disagree with Lawrence Krauss on this, don't take philosophy seriously enough, especially when it comes to the foundations of physics. Think of stuff like quantum mechanics. You need to know, like, where does the science end, where does the philosophy start? And I think physicists are really, really bad at figuring out where they cross over into philosophy, and this is where a lot of things go wrong. And I wrote about some of these issues already in my first book, when they make mathematical assumptions that are actually metaphysical, and they don't see the difference. So they think it's a requirement. It needs to be. It's mathematical, right? When it's actually, something else that they postulate the laws of nature must be like. And so I think that this is a huge problem, which is why I got interested in that. And then, as you probably know, philosophy is kind of a rabbit hole. As once you start looking into it,
That's for
there's no
sure.
end.
I, I'm really interested in what you said about, I guess, like philosophical assumptions that people unknowingly embed into their scientific worldview. So famously, Albert Einstein sees that his equations point to a finite universe or something like this, and so he adds in his cosmological constant to his equation so that the universe could be eternal, because of course philosophically he knew that the universe had to be eternal, just like Aristotle thought and everyone in between. And so he adds in this constant and later takes it out again and calls it his greatest blunder, right? And that blunder that Einstein, if Einstein can do it, we can all do it, made was a result of essentially a philosophical assumption that, well, the universe has to be eternal because otherwise it sort of wouldn't make sense. And we now don't think that's the case. At least this universe is probably not eternal. But that philosophical assumption changed what Einstein ended up, finalizing his equation as, if I'm not mistaken. And I suppose that's something that can sort of crop up everywhere. one of the really big assumptions philosophically that seems to send people into an absolute frenzy when it comes to all areas of science is the existence of free will. You've already mentioned it, but there's a particular area of application here. Now, I'm hoping you can help me understand this. I did a video recently called The Existential Crisis Iceberg, where I went through all the different levels of ideas that might give you an existential crisis. And somewhere near the bottom was this thing called superdeterminism. Now, superdeterminism is something like determinism, but as applied to the quantum realm. Everything is ultimately fundamentally determined. And if I'm not mistaken, a lot of physicists reject this. They say superdeterminism is nonsense, and at least a lot of them do that because they have to assume that free will exists, or something like that. Can you help me understand what's going on there?
That's a very interesting question. I think this has a long historical backstory. So, if you don't mind, I'll try to briefly summarize it. So, we already talked about Einstein. Einstein, for all I know, didn't have any strong feelings on this free will thing, but Niels Bohr did. So, Niels Bohr, interestingly enough, thought he wanted quantum mechanics to be indeterministic because he thought that makes room for free will, which I think is a position that most philosophers now reject. But for him, it was that's actually what he wrote, if I remember this correctly, in some letters to Einstein. So for Bohr, who's often credited with being kind of the father of the Copenhagen interpretation, this was really important. So now Einstein had misgivings about quantum mechanics that didn't have anything to do with free will, but it was that the measurement process, so the collapse of the wave function, is faster than light. And of course, Einstein didn't like this, right? This is what he called spooky action at a distance. So he tried very hard. He had a long argument with Bohr to try to pin it down, like something is wrong, and he ultimately failed at it. But he had this idea that there is an underlying, probably deterministic reality in which particles all have definite properties. So there's nothing of that sort going on, that you can't measure two things at the same time, or that particle goes into places. He didn't like that sort of stuff. He thought a particle goes one place, and that's at the end of the story. We just don't know where the particle is going. So, so Einstein died, and then came John Bell, who tried to finally pin down the difference between the Einstein view and the Copenhagen interpretation. And this is where Bell's theorem comes from. So he said, let's assume that Einstein was right, and there is this underlying reality which is deterministic, and it has no spooky action. It's local. There's nothing like a collapse going on. Then what are the predictions that this sort of theory generically would make, and how does it compare to quantum mechanics? And so now, here's the thing. In his proof, he made an assumption, which is now called often the free will assumption. And you need this assumption that the experimenter has free will to derive this inequality, which basically says that the Einstein type local deterministic theories, obey an inequality which we know experimentally is violated. So if you make this assumption, if you make the free will assumption, then the Einstein idea is ruled out. If you throw out this assumption, you get what's called superdeterminism. And then you can reproduce our observations with a local deterministic theory of the type that Einstein might have had in mind, or might not. Unfortunately, we don't know what he would have thought about this. But so this is the reason why free will became tied up with this superdeterminism thing. Now, the issue is, though, that if you look at exactly what do they mean with free will, it doesn't have anything to do with what philosophers normally, or even, standard people on the street. Let's not even talk about philosophers mean by free will. It's an assumption that's more technically it's known as measurement independence. It's got something to do with the correlation between the thing that you want to measure and the measurement settings. You can choose measurement settings with a computer. It doesn't necessarily have anything to do with free will. But so this is where it came from. And I think part of the reason this happened is that Bell himself, in his original proof of the theorem, seemed to have not noticed that he even made this assumption. So this was later pointed out to him by, among other things, John Clauser, one of the guys who won the Nobel Prize in 2022. That there was this extra assumption, which Bell then justified by alluding to free will.
I
So,
see.
you can kind of think so. Like, he must have thought, like, "Damn!" Right?
Yeah.
So suddenly there's this hole in his theorem. So he had to come up with a reason for why we need this assumption,
And
so
that
he
was
called it
free will.
that was free will. Yeah.
Interesting. So let me see if I've got this right. Right. So we've got this weird quantum stuff that goes on. People can imagine like the double slit experiment where there's like a wave pattern, but if you observe it, then it's a particle. All a little bit strange. And so there's this Copenhagen interpretation which says that the electron is actually a sort of cloud of probability, a wave function, which is a sort of prediction of probabilities of all the places it can go. And when you observe it, what happens is that wave function collapses, so to speak, and the particle is in a particular place. And that happens when you observe it. Before you observe it, there's this big wave of probability. The problem is that if you've got this wave of probability that goes from my left hand to my right hand, and then I observe it and it collapses and the particle's on my right hand, there needs to be this information over at my left hand that the particle isn't there. But because it happens instantaneously, this information seems to travel from my right hand to my left hand in an instant, which means faster than the speed of light. So Einstein says that can't happen. Therefore, this idea that the electron is just a cloud of probability is wrong. There must be some kind of, foundational nature. It must have a foundational property. We just don't know what that is yet. And so after this, Bell wants to retain the idea that information can't travel faster than the speed of light, that everything is local, in other words. It has to, if it's at my right hand, it stays at my right hand. It can't just zip across space instantly. And in order to retain this locality, he comes up with this Bell's theorem. But that theorem assumes something. It assumes something about the way that the scientist interacts with the experiment, which is an assumption, but he doesn't realize is an assumption. And only later, when that assumption is pointed out to him, he says, okay, well, if we didn't assume that, then free will wouldn't exist. And that was the reason he gave for agreeing with this assumption. But we could just deny that assumption and everything still works. Something like that?
Yeah, almost. I made 2 notes about things that I'm slightly unhappy with. One is you said something about the way that information travels. So there isn't actually any information being exchanged. This is actually the big headache, because if there was information being exchanged faster than the speed of light, then we could measure it. So the entire problem with the collapse of the wave function is that it's completely unobservable. So there's nothing observable actually going faster than the speed of light. I mean, it would actually be cool if that was the case, right? Then we could send information faster than the speed of light, but that isn't so. So this is the one thing. The other thing is that mathematically, this assumption to Bell's theorem doesn't really have anything to do with free will. That's just an interpretation. So what it really is, like, mathematically, it's a type of correlation between things. And you can try to connect it to the choice that the experimenter has in setting, deciding what to measure. You can actually, since you mentioned the double slit experiment, you can actually see in the double slit experiment why that helps. Because one of the weird things about the double slit experiment is, so you have these two slits, and then you get a wave pattern that comes from the interference of the two parts of the wave function that go through each slit. So so the weird thing about this is that the one particle, even if it's only one particle, it kind of needs to go through both slits to interfere with itself. Because if it goes through only one slit, it can't interfere with itself. So now what you can do is you can put a measurement device into one of the slits. And what happens then is what you said, is that the interference pattern goes away. Because now the particle kind of, it knows I'm being measured. So it goes only once. So either it goes in the detector, then the detector goes pling, or it doesn't, then it goes through the other slit, but you don't get the interference pattern. So now I think you can see from this example that if what the particle does it split up or does it only go one way, is correlated with what you measure. Do you measure at the slit or do you measure on the screen? Then you can explain what's going on. Because if these two things are correlated, then you have a deterministic variable that tells you, does it go through both slits or does it go through only one?
Yeah.
So this is basically how superdeterminism works.
If there is a correlation between, the observation of the phenomenon or the way that you observe the phenomenon and what actually happens, the phenomenon itself, if there's some kind of correlation between those two, between my looking at the particle and what the particle does, or the detector and what the particle does, then, that's fine. There's no problem. That's why it acts differently when we observe it and when we don't, because there's some correlation between us observing it and what it actually does. But the thing that Bell assumed is statistical independence, right? That is, that there is no correlation between your observation or the detector and the phenomenon itself. And what a physicist...
so it's not that there is no correlation between the observation, but between what you observe.
Right.
So it's like the variable that you actually measure.
Sure.
Is
so
like
what you observe,
the path or the interference on the screen. Yeah.
Sure. So Bell assumes that there is no correlation between those two things. But as a physicist, you could assume that there is a correlation between those two things, and that would mean that Bell was wrong. But Bell wants to say, or at least that his theorem is
right.
incomplete.
Yeah, I mean, look, it's a proof, right? And I think no one doubts that the proof is correct. You make assumption ABC, you get results so and so, and then there are like 10,000 people have repeated. I'm pretty sure it's correct, but there's like the question is, what does it tell us about reality? Like this is the question, right?
Sure. Okay, so why is it then that when Bell is asked about this, and someone says, "Hey, you've assumed that there's no correlation between observing the path and the result of the where the particle goes or whatever," why does Bell then say, "Oh, well, we have to assume that because otherwise free will wouldn't exist"? Well, how are they connected? At least in Bell's mind.
Well, that's a very good question. So for one thing, there's generally the issue: how do you reconcile free will with determinism?
Yeah.
Even forget about the super. Like this is already difficult. So and we could stop at this point and say, well, it's deterministic, so free will goes out the window. So this is one answer. The other answer is that what Bell had in mind, and sorry, I'm trying to think of a way to not make this too technical. So if you think about what we just discussed, so what the particle is doing, does it go one slit or both, needs to fit together with the measurement that you make. So it somehow seems that the measurement needs to be just right to fulfill this correlation. And so now your choice of measurement in a deterministic theory always came from an earlier cause. So you can trace everything you do and say and think can be traced back ultimately to the beginning of the universe. And what Bell, I believe, had in mind, and many other people have later said similar things, is that if you believe that this correlation exists between what the particle's doing and your choice of measurement, then your choice, the choice you will go on to make, must have been correlated with what the particle will make all the way back at the
Yes.
beginning of the universe. And
Yeah.
that seems like an extremely unlikely coincidence, and it's often called a conspiracy of sort, that these two things would fit together uh, in that exact way. So I find this argument quite misleading, because you can always make, like, forget about quantum mechanics. Like, every time you measure anything, you could say, well, but actually my act of measuring this particular thing, or having chosen to study physics, or eaten this thing for lunch, has other causes, which goes back to other causes, which goes back all the way to the beginning of the universe. Like, you can always say that, and then you can always say, oh, there must have been a great conspiracy in the universe to put together all the atoms of your body so that you came out being exactly the way you are right now. Okay, but no one ever makes this argument. So why do you suddenly
Yeah.
make this argument for this particular detector setting?
I think
Okay.
that confusion crops up all the time. So just to make sure that I'm understanding what you're saying, we said that the thing Bell assumed is that there is no correlation between like my observation and the effect of the experiment, or the result of the experiment. There's no correlation there. And he says, well, if we assumed a correlation, then free will wouldn't exist. Why? Because if my observation is somehow correlated with what the result of the experiment will be, that implies that both what the result of the experiment are and whether or not I chose to observe it in that way must sort of have been already preordained, because how else could they be like correlated and connected unless they both stem from some prior cause, right? So if you do assume that there's a correlation between the observation and the effect, then that's you could do that solves the problem, but it means that there's no free will, because that means that your decision to observe it in that way must have been caused by something prior. And so Bell looks at this and goes, well, I don't really want to assume that there is a correlation. Why not? Because there'd be no free will, because there'd be no choice. But you rightly point out that the problem for free will is much wider and prior to that. I mean, an example I often give is, suppose we're talking about quantum mechanics and whether there is randomness in quantum mechanics or not, right? Is everything determined, or is there some kind of randomness in quantum mechanics? Some people want to say, well, there has to be randomness in quantum mechanics, because otherwise there could be no free will. Because if everything was ultimately determined, there'd be no free will. And so if there's no randomness in the universe, we'd have to do away with free will. And it's kind of confused, because even if there is randomness, or whether there's not, the point is that you're not in control anyway, right? Like, the idea that you want to retain this quantum randomness because otherwise you've gotten rid of free will, it's like, before you even get there, you've got 100,000 reasons to give up your belief in free will. So at this point, if your only justification for retaining quantum randomness is to keep free will, we lost free will ages ago. So that's not a good reason to keep this quantum randomness. And the same kind of thing applies here. Mr. Bell, Dr. Bell, if your only reason for assuming this correlation, or that there's not this correlation, is because of free will, like, dude, like, we forgot about free will ages and ages ago, right? So something kind of like that, I think, is maybe what you're getting at.
Yeah. So I totally agree with you about the issue with the randomness. I think the idea that people have is like, you have this randomness and you get to choose
Yeah,
what the pick is. But then, of course, it wouldn't be random, right?
yeah.
So it's not how it works. So honestly, I think a part of the reason that it's often referred to as free will, this assumption in quantum mechanics, is because that looks good in the headlines. Like, there was just like last week, there was an article in New Scientist about the free will assumption. It was, and the headline was something like, "This experiment can rule out free will," or something, and it's about testing superdeterminism, which I'm very interested in. But why do they have to make it about free will? And so you read the article, and it has this interesting line which says that if these correlations in superdeterminism are real, then that would the laws of nature would constrain what we can do. But the laws of nature always constrain what we can do. Like, you don't even have to talk about superdeterminism. Like, gravity constrains what I can do. Like, this is like, if it wasn't so, it wouldn't be called a law, right? So what superdeterminism does is it adds a new constraint, like which is this correlation, and yeah, that would constrain in some sense what the experimenter can do and can't do, because the actions have to fit together with what the other thing does.
Yeah,
that's how
it's as if you've got like a car that's completely broken down and can't run at all. It's just completely broken, and someone comes along and they smash in the front window. And somebody says, "Oh, if you smash in the front window, then the car won't work." That's true. Yeah, if you smash in the window, the car won't work. But it wouldn't work anyway. It wouldn't work even if you didn't smash the window in. Like, oh, there's no if the universe is determined, if superdeterminism is true, then there's no free will. Yeah, that's true. But there was no free will anyway, even before the superdeterminism stuff came in. And I think there's a lot of confusion there. And you're right. Like, people will connect this idea of free will and determinism so that anytime a story comes out, maybe the universe isn't deterministic, the headlines run, "Oh, look, there's room for free will." But there's just not. They aren't as connected as people actually think they are. And that's something I try to make a point of all the time. When people say to me, "Do you believe in free will, or are you a determinist?" And I say, I think neither, I'm not a determinist. I don't know. I'm agnostic on that. But I still don't think free will exists, regardless of whether everything's determined or not. It's like much, much prior to that. To explain why would require philosophical argumentation, which I'm not going to get into now. My listeners will be bored to high heaven already of hearing about it. But one thing they might also be bored of is something I've been talking about quite a lot recently, which is this idea of panpsychism, the idea that everything is fundamentally made up of consciousness. And the reason I've made a rather sharp little detour there to mentioning it is just because you said earlier that an example of bad philosophy is panpsychism. I've had a few panpsychists on the show. I've had some people who are agnostic about it and think it's interesting, but I don't really know about it. I've never had someone on, at least not yet, who says that it's bad philosophy. Why do you think it's bad philosophy?
First, before I answer that question, I want to say something about your wrap-up of this free will in superdeterminism thing, because I think it's relevant to note that the people who make this argument about free will, they're all physicists. I've never heard a philosopher make this argument. So this entire connection to free will and all the blah blah about it comes from physicists, and this is an example of why I say I think physicists should pay more attention to what philosophers are actually saying, and maybe look up what do they even mean by free will and so on.
Yeah, it's like we don't mind when physicists say, "Hey, there's this interesting finding that the universe isn't deterministic." Cool. That's great. That's physics, and I would never hope to understand how or why you could know that. But I do know that that is not a good justification on which to say, maybe free will exists. Like, maybe you should speak to a philosopher before making those grand philosophical claims.
Basically. Yeah, so about panpsychism, but basically, my opinion about this is the following: that there are two types of panpsychism. The one I'd say is properly philosophical, and it's a kind of a flavor of dualism. So it's something that science can't test, and some people think it explains something. Then we can talk about what does it mean to explain something. And then there is a version of panpsychism which has a physical element. It gives attributes. New attributes to particles and to everything else, which is this consciousness attribute, in which case I'd say, well, if that's a physical thing, you're doing physics, and what you're saying is actually wrong. And then you can take a pick, either your theory of panpsychism is wrong, or It's untestable.
What is the thing that would be flatly wrong? Like in terms of someone's physical understanding for that second kind of panpsychism, what is the thing that they're getting wrong?
So some flavors of the panpsychist theory, they have this idea that they call proto-consciousness or something.
Uh-huh.
So this is like little elements of consciousness, and if you combine sufficiently many of them, then consciousness comes out.
Uh-huh.
And so if you do anything to an elementary particle which isn't already there, which isn't in the standard model of particle physics, if it can do anything, like if it has any properties, then we would have been able to see this already. So either it doesn't have any influence on what's going on in the human brain or whatever, then it doesn't explain how consciousness comes about, or it's in conflict with what we have already measured.
Hmm. What do
So
you
so
think?
the only so sorry, one thing. So
Uh-huh.
you can of course say that this proto consciousness just doesn't have any properties whatsoever. But then again, it doesn't explain anything, right? It must be able to do
Hmm.
something at some point.
So what do you think then of this idea that I mean, the panpsychist of at least one stripe says that the fundamental stuff of the universe is consciousness. Like, what is everything ultimately made of? Oh, well, atoms. What are atoms made out of? Protons, electrons. Well, what's a proton? Oh, it's made of, I don't know, gluons, muons, truons, whatever they're called. What's it all made out of when you get to the bottom? And the panpsychist says consciousness. And it sounds a bit kind of wacky and strange. But one thing that it might sort of point to is why is it that certain subatomic particles seem to do one thing versus another? Like, why is it that electrons are negatively charged? What does that mean? It means that they repel other negatively charged electrons. Panpsychists might look at that and say, a scientist can't explain why it does that. It can explain that an electron does that, but it doesn't tell us why. Maybe the reason is because the electron has some kind of rudimentary preference, and that's what's causing this kind of differential behavior between subatomic particles. And so when the scientist looks at the fundamental stuff of the universe, electrons repelling other electrons, actually they are observing a very rudimentary form of preference. It's just that they're not thinking of it that way. Humor me. Tell me what you think of something like that.
Well, I would say that doesn't explain anything. That's just a story that you can tell.
Mm.
So, unless you can actually write it down and make a prediction with it, I'm not
Mm-hmm.
having it.
Mm.
So, of course, you could say, well, everything is made of the same fundamental stuff. Let's call it consciousness. I don't have a problem with it. This is basically a theory of everything. But just by giving it a name, you haven't explained anything. You need to tell me, well, how is it that your consciousness stuff, if you want to call it that way, differentiates in particles that have exactly those properties that we observe? Think of string theory. If you want, why not call the string consciousness? So, are you happy with that? If you're a panpsychist, if not, why not?
Yeah, because it doesn't explain anything further. One of the criticisms that people make I say criticisms, one observation or idea that people make about science as a whole is that it's purely descriptive. I talk about this a lot too. And I like speaking to physicists about it. I spoke to Brian Greene about this, for example. The idea is that science only describes things. It doesn't actually explain anything. Isaac Newton is the most famous example of someone who almost perfectly describes the mathematical laws by which the planets all sort of orbit each other and all of this kind of stuff, and describes it with perfection. But when he considers what gravity actually is, or like why it acts in accordance with those particular properties, he says, I've got no idea. Hypothesis non fingo is what he writes. Some people extend that to science as a whole. They say that, okay, so you've told us that an electron is a negatively charged particle. Cool, but why? Like, why is there this thing that repels other negatively charged particles? Where do you fall on that debate? Do you think that science is completely descriptive, mostly descriptive, or that it does actually give us an explanation for why phenomena exist?
Well, I would say you have a weird notion of explanation. So first
Mm.
of all, yes, I think science is totally descriptive. Like, what else would it be doing?
Mm.
Um, but also, like, if you make your assumptions or hypothesis, or whatever you want to call them, your axioms of your theory, and you can use that to make a prediction that's actually correct. I would call that an explanation. And it's actually the best type of explanation that we have. And by construction, any theory will always require some sort of assumptions that you cannot explain further. Like those are like the basic axioms where you say, okay, a particle is described by, I don't know, a vector in a Hilbert space with some symmetry group or whatever. And so this is the basic assumption of your theory, and then you use that to derive what we observe.
So this predictive power is important here. Can I give you one idea then, or one thought experiment as we sort of look to wrap up here? I'm imagining, right? So I'm going to do that thing that philosophers so often do, which is come up with completely ridiculous scenarios that hopefully will be instructive to some degree. Suppose I discovered that there was this trumpet, like in this room over here, and if I played a particular note on a trumpet, then a red light turned on over there. And if I play it quietly, it turns on quietly, and if it turns on very, very dimly, and if I play it loudly, it's very bright, and so on. And I'm like, I don't understand why it's doing that. I have absolutely no idea, right? But what I figure out is I describe with perfect accuracy, the relationship between if I play this note at this volume, we get this kind of brightness, and if I do it louder, then I get a brighter bulb. And I come up with a perfect mathematical description that accurately predicts exactly what will happen to the light bulb when I blow through the trumpet. So now I've got this mathematical system that perfectly describes and predicts with every time I try it, it's 100% accurate. It tells me exactly what the light will do when I play a particular note on the trumpet, right? So I've completely and utterly predicted exactly what's going to happen. If somebody then asked me, but why does blowing the trumpet make the light turn on? Like, what's the explanation for why that's happening? And I said, well, look, I think I've explained it as far as I can, which is by coming up with a mathematical description which accurately predicts what will happen in the future. I would feel like that hadn't actually explained anything at all. And do you think that, do you understand the criticism I'm making, I suppose, when I say that it sounds a lot like that might just be what science is doing in general, right? When you've got this great mathematical explanation and this perfect prediction, using that mathematical description, to say that that is enough to have explained the phenomenon sounds a bit like the person who thinks that we've explained why the trumpet turns the light on just by coming up with a predictive mathematical model.
So I would say that so you can always ask for better explanations. So maybe you're not satisfied with your trumpet story because you feel like there must be more going on. That's fair. So I don't think that these are exclusive. So your trumpet theory explains something, but there might still be something deeper to be explained. And this is, I don't know if you know this clip of Richard Feynman where someone asks him but how does a magnet work, or why magnetism or something, and he gets really frustrated and he says, well, in a nutshell, he talks for a while. He says magnetism is just one of the fundamental forces of nature. Like it's one of the deepest explanations that we have. The electric and the magnetic force, and then we have some other forces, and everything else builds up from this. But there's always a deepest level of for any moment in the history of science. We have a deeper level where we have no further explanations, where we can just say that's it, right? We've gone that far. So magnetism is just there. It's how the universe works. And then you can still ask, but why magnetism? And maybe there's a deeper explanation, and maybe there is a theory of everything. Maybe string theory is correct, or maybe something else. But I think science will always have this end of why, and then you can still ask another why.
It seems to me that trumpet situation, once I've come up with that mathematical description, it almost feels like I don't feel like I've explained it to some degree, but maybe there's more of an explanation. I kind of feel like it doesn't explain anything, like it predicts what's going to happen, and it describes mathematically what I'm observing. But in what sense, like to any degree, do you mean to say that I have at least partly explained like what's going on with the trumpet and the light? What do you mean by that word explain in that circumstance?
Well, suppose there's someone in the other room and he sees the light going on and off. Sometimes the light goes on and off. And you tell them about your trumpet theory. And then we'd say,
right.
oh, that explains why the light keeps coming on and off.
Okay, I see. And but if they then said, but why does the trumpet turn it on? Then you would need a further explanation. But to at least some degree, I would then say in at least some contexts of like the information that you're looking for, it might explain something. But man, I suppose those listening can decide for themselves. And hey, let's boost some engagement. Leave a comment in the comment box down below as to whether you think that counts as an explanation or not. I'm still not sure, but it's one of the great thrills of doing this podcast that I get to ask people from all different kinds of fields. So I've asked the same question to Brian Greene and other physicists. I've asked the same question to all kinds of philosophers, and the one thing that's becoming evidently clear to me is that nobody seems to know for sure. But I appreciate you taking the time to run through some of these ideas with me, and it's been fun. And if anybody is having an existential crisis, there is more to say. There are deeper levels on which we can discuss these things. Your book is Existential Physics, which should be an attractive enough title to anybody who's listened to a podcast like this for this long, and I'll leave it in the description down below. But with that being said, Sabine Hossenfelder, thanks for coming on.
Lovely to talk to you.
If you enjoyed that conversation, you might like my previous episode with Brian Greene, talking about string theory, the multiverse, and the limits of scientific explanation. Watch it by clicking the link that's on your screen. To support my work and get early, ad-free access to episodes, subscribe to my Substack at alexoconnor.com. Thanks for watching.